You even had most of you decided to take the day Friday, so you super had long enough. Let's see, 4 can get a point because they got quiet. Let's see, 3 can have a point, 2 can have a point, 5 can have a point, 1 can have a point, 6 can have a point. Finally, goodness. 2 what? And 1 can have another point. Thank God someone came to do math and math classes today. Okay, let's get started. We have new math workshops. We did not finish the last one without you, like number 18 or so. We're going to just let that one go. So the last question on the last workshop sheet that we never answered, we're going to let go. What you missed on Friday is we went over some more problems on graphing. So if you're struggling with graphing quadratics, you probably would watch the video. We also had time during class. Well, I'm not talking to people. We also had time during class to work on our checkpoint and on our homework inside our packet that's on page 7. It was 6 problems. You have to do 6 things. It's 36 points. I'm not going to type in the 0 for it today, but in case you can't read, you have a quiz tomorrow, I'm going to type in the 0 then. So it was 6 problems. 6 problems, page 7. So if you missed Friday, that's what we did. However, we cannot get any further behind. So, I mean, I don't mind you taking a day, especially after a late game, but we got behind. So, let's talk about how to get caught back up. Today, we have to do one new thing, and it shouldn't take that long. After we do the one new thing, literally after we do the one new thing, it's going to be time for you to get any of that done that you need to get done. I forgot what words are going to come out. Maybe they'll come in a second. So we have one new thing. What we need to do is we need to finish up the rest of 4.1. There is a little left. We need to finish it up, review Monday, and test next Tuesday. But in order for that to happen, since Thursday is going to be a hot mess, more than likely there's going to be one day of notes that I'm going to just have to record a video. So Seth can choose to watch the video Thursday, Friday, Saturday, Sunday, doesn't matter when. But regardless, whatever's on the video could be on the test that's next Tuesday as well. So if you were wanting to put in your planner what's going on when, you have a quiz tomorrow, and then exactly a week after that you have a test. Now you'd think life would move a little faster than that, but we're doing the best we can. Okay, Table 1 already told me to pull out a 12 on our first math workshop, which is correct. Not only are we going to pull out a 12, we're going to pull out a 12xy. What will we be left with?
3x minus 4y.
Okay, 2 and 3 can have a point. Number 2, what are we going to do?
Pair them.
We are going to do grouping. Table 3 can have the point. Do we need to rearrange in order for it to group, or is it going to work out like this?
It's going to work out like that.
Oh, okay. So if we group, what can we pull out of the first group? What are you left with?
4a minus 3. Then pull out the 3 from the second group, and with the positive 3, then you get 4a minus 3.
I think you had to pull out a negative 3 in order for it to be a minus 3. Yeah, it's going to have to be a negative 3. Okay, so my final answer is 2x minus 3, 4a minus 3. I know I gave Day a point, but I'll sure I need to give you a point too because you handled that. So 1 and 2, pretty easy so far. Number 3 is one of my favorites because it's got a leading coefficient of 1. It's got a leading coefficient of 1. Okay, on number 3, because it's got a leading coefficient of 1, I just need to think of something that multiplies to 8, adds to 6. 4 and 2, Seth said it first, but I'll give Kelsey a point too, so 1 and 6. So x plus 4, x plus 2, that's great. Number 4 is probably my for real favorite of the day, because it is, who said it?
I did. No, you didn't.
Did you say it, Kelsey?
Is
Mackenzie said it.
Who said perfect squares? Thank you, Mackenzie. Table 4. Okay, so I know my perfect squares. I know that 2 squared is 4, so I know it's a 2b. What's 625? Yes, 6. So I have 2b minus 25, 2b plus 25. I need to say those words in just a second. Let's do number 5, and I'll say those words. Number 5 is a 7, 8 to the third, plus 53a plus 28. Oh, sorry, 7a to the second. That makes it even better. You know what? This would be a really nice problem if the middle term was a 56. Because then everyone would have been indivisible by 7. But it's not right now. Again, the way I like to do these, and we're going to actually, this is one of the things we're going to talk about this week.
So is this number 4 or 5?
This is number 5. We've done 4. It's down here. The way I like to handle these, let's see. Who is on my nerves? Easiest way to explain this. We're going to discuss another way later this week, but for me, I think the easiest thing to do is to think what multiplies is 7. The only things that work are 7 and 1, so I'm going to have a 7a and an a. And then our last we know needs to multiply to 28, so I think through things that multiply to 28. So I could do 1 and 28. I could do 2 and 14. I could do 7 and 4. And I believe that's about all I'm going to come up with. And I'm really wanting somehow, so if I guess, and they're all going to be positive since I've got both a positive middle term and a positive last term. So I might just guess, because I'm just going to guess and check. Maybe it's a plus 7 and a plus 4. I really don't know. Literally guess and check means I guess something, I check it. If I'm wrong, I guess something else. Okay, when I FOIL it out, I'll have 7a squared plus 28a plus 7a plus 28. So I'm wrong with my guess, because when I add 28 and 7, I get 35. I don't want 35, I want 53. So this is incorrect. So we could change it. How could we change it? You're going to say what? Okay, so Miss Brewster says, why not just swap the 4 and the 7? Instead of 7a plus 7, why not try 7a plus 4 and a plus 7? And we'll just literally guess and check means I guess something, I check it. If it works, great. If not, go something else. 7a squared for the first, 49a for the middle, 4a, first, outer, inner, and then 28. What's 49 plus 4? Oh, and that's what I wanted. 7a squared plus 53a plus 28 is what we started with. So my two factors really are 7a plus 4 and a plus 7. Miss Brister was correct. Again, your teacher might have taught you a different way, and we'll discuss different ways later this week. But if you understand how to guess and check, I really think it's just easiest to guess and check, and that really shows you understand your multiplication factors. Okay, are there any questions about these math workshops? There is something coming up that we keep postponing that we can postpone no longer. So on Wednesday, we are going to take a perfect cubes test. I'll even put them on the screen for those of us who don't know where ours are. It was on the back of the last packet. I know it's on the screen, and you can cheat and look at the screen if you need to. Life is what it is. But we're going to go through these now. We've already done 1 through 3, I believe. We're going to go through them now. We'll go through them again on Tuesday, but seriously, it's up to Paige as to whether or not she knows them on Wednesday. Do you think I'm going to give Paige long on this? Probably a minute. Maybe not. Maybe a little longer so she can write her name, like a minute 20, but a minute. Okay, let's see. 1 cubed is 1. 2 cubed is 3 cubed is 4 cubed is 5 cubed is 6 cubed is 7 cubed is 8 cubed is 9 cubed is 10 cubed is? Okay, why was it not good the way I did it? Thank you, table 6. You can have a point. So can table 5. I went, and 1, you said it too?
I did.
I can't go, the test is not in exact order, so let's do them random now. 3 cubed? 5 cubed. 8 cubed. 10 cubed. 1 cubed. 2 cubed. 9 cubed. 7 cubed. And then 6 cubed. Okay, if you actually knew those, good for you. If not, you're in trouble. That's on Wednesday. You've got, I'm going to say a minute 20. I'll give you 20 seconds for your name. Your name's real hard, I guess. Okay, looking at your new packet, let's go to page...
What new packet?
Not new, but the packet we've been working on. Okay, so we've already gone over how to graph a quadratic. We talked about it was called a parabola. We talked about how Miss Compton is lazy, and instead of actually making a table or make the graph, I just use my calculator. I get you know how to too, or you're supposed to. If not, you need to rewatch the video or ask a question, because I'm telling you quizzes tomorrow. What we've been doing is listing 6 things. The y-intercept, the axis of symmetry, the vertex, max, min, domain, and range. Some of those things we can list automatically. You can automatically list the domain. You can automatically list that y-intercept. You can automatically list if it's a min or max. Maybe not where it's happening, but you can automatically list those things. We've talked about over and over again how to do this in our calculator. If your answer is a whole number, you can use that table of values to help you figure out most of this stuff. But if it's a decimal, what do I suggest you do? Like if the vertex is at a decimal, like on number 2 of your checkpoint, what button should you press on your calculator? Instead of second table, you're supposed to hit second and then what? Second calculate, yes, 6. Second calculate. If you go to calculate and you tell it, for instance, min, you pick a little to the left, a little to the right, you make a guess, it tells you the answer. Okay, so there's one tiny new thing we need to discuss before we're ready for a quiz. And it is on page 4. I think I wrote notes page 9 through 11, but instead we're just going to do page 4. I wrote the things wrong on the board. I need to fix that. Okay. The last thing we need to talk about is how to solve a quadratic equation by graphing. Now, you're not going to be surprised. Later this week, we're going to discuss how all the factoring you've been doing has actually been giving you answers all along. But for today, we're not even going to worry about that. We're literally going to talk about how we can solve by graphing. Okay, so I'm going to skip some of the stuff at the top. Let's go straight to the box. Okay, so when we've been graphing so far, we've talked about the vertex, we've talked about that axis of symmetry, we worried about that y-intercept. The one thing we haven't talked about that I kept crossing out were the x-intercepts. So today, literally, all we're going to talk about are x-intercepts. Now, the x-intercepts are so special, they have different names. Sometimes your teacher might call them roots. Sometimes the teacher might call them zeros. They all mean where is it crossing the x-axis. Okay, so we've got 3 examples in this box. This graph crosses once, this graph crosses twice, and this graph doesn't cross at all. So needless to say, this one has 1 root or 1 0, this one has 2, and this one has none because it never crossed. So it's okay if you get that your x-intercept is no real solution, but I probably shouldn't write 0, should I? I should probably say doesn't cross, no x-intercept, no root, no 0. Put something besides the number 0, because if you put 0, I'm going to think you meant it crossed that 0. So maybe that notation is bad. We probably shouldn't put that. We should probably just say it didn't cross at all, because if we put 0, I'm going to assume you meant it crossed once at 0. Yes, dear?
Does no solution also count as 0?
Yes, that would work for me. Okay, so what we're going to do is literally put these equations into our calculator and then determine where those two roots happen. Later this week, we're going to talk about how to calculate that by hand, but as for today, literally it's just can we put it in the calculator and determine where those zeros or roots happen. Thankfully, the first three they've already done for us. They have already done 1, 2, and 3. On number 1, what should I put as my answer?
No root.
Okay, on number 2, what should I put as my answer? There are 2 roots, but then can you tell me exactly where those roots happened? Every group can have a point. And the last one has 1 root, and it's at 1, 2, 3, 4, negative 4. So theoretically, back to Seth, if he's given the 6 parts we talked about before, he can graph it. But at least now, if he's told roots at negative 2 and 5, he knows if his... He might not know up or down, min, max, that kind of thing, but he knows it crosses at negative 2 and positive 5. So either it's going to look like this. Well, hopefully I can hit both dots. My gosh, Miss Compton. Or it's going to look like this. He already kind of has an idea of what it looks like by knowing those 2 roots. Okay, and then we want to start. We only have 4 problems, and then it's on you. What's wrong with number 1?
It's not in standard form.
It's not in standard form. Oh my goodness, everybody can have a point. That like makes my whole day. I almost want to cry. That's brilliant. So we've got to move that 12 over. It needs to be x squared minus 8x plus 12 equals 0. Okay, so we need to type this in our calculator. So x squared minus 8x plus 12. You don't actually put the equals 0 part. You literally only put the stuff that's in standard form. So I've just typed in x squared minus 8x plus 12. I press graph. It looks pretty nice at Zoom Standard, and I think I can see where those roots happen. Tell me what you think. 2 and what?
Yep, 2 and 6.
3 had them first, so we're going to say 2 and 6, and table 3 can get the point. Okay, how did you figure out it was 2 and 6?
That's the divisions of 12. Or the 12.
Okay, but what buttons did you press on the calculator? Did you press any buttons? Like, I got this graph.
Typed it in for y equals.
Okay, so I did that, but, I mean, you could hit trace, and then if you hit trace, you could say for sure, when I go, I'm scrolling. It does look like it's 2, but again, it says like 1.9, something, and that's confusing. So trace again, trace is just such a letdown of a button. I don't, it's so disappointing. You could always look at your table, and we're wanting to know when y is 0, what is x. So yes, I do see on my table, let me turn my light on, hold on. You can focus faster than that. You can do a better job than that, come on. Okay, so when I look at my table, a root or a 0 happens when y is 0, so I could scroll through my table and find out when y is 0. So it's 0 at 2. And she's right, it is 0 at 6, so it is 0 and 6. And so we're going to get, I mean, it is 2 and 6, because that's where both the y values were 0. So they're correct.
So you can get that if you hit the table.
You can get it from the table, and you know, so smart. You know there's going to be one in a second that's going to be decimal answers, so I'm going to press second calculate and do zeros with it. That's why there's a 0 button on it. Okay, let's go to number 2 and rearrange that bad boy. Number 2 is all kinds of messed up. It's got people on both sides. I need to move all the numbers to one side. So I'm going to, opposite of you, because you would tell me to subtract x squared. I don't want to do that. So I'm going to add 2x to both sides. So I have, and I'll write it one step at a time if you need it, 12 equals x squared plus 2x plus 16. I'm literally just moving the 2x to the right side. And now I need to move that 12 to the right side, so I'm going to subtract by 12 on both sides. And I get x squared plus 2x plus 4, and it all equals 0. Now, if you wanted to rearrange it differently, you could. Yours would just have different signs than mine. That's not necessarily a bad thing. But again, all I did was move the 2x over. That's why he jumped from the right side to the left side. He used to be negative, now he's positive. The 12 was positive, so I subtracted 12 from both sides. 12 minus 12 is 0. 16 minus 12 is 4. So I'm going to type in my calculator, x squared plus 2x plus 4. Okay, so I got to see it for myself. X squared plus 2x. So this would be way too easy if it was just, hey, graph all these, they're already in standard form. So of course they got to make it a little complicated. So 2 and 3 are correct. When you graph it, it doesn't ever cross that x-axis, so it actually has no solution, no roots, no zeros, however you want to phrase that. I'm just going to put no roots.
So there's no roots?
Yep. Number 2 never crossed. So we're done. Yes, dear? Yes. I did x squared plus 2x plus 4. I pressed graph. I got this. X squared plus 2x plus 4. Yeah. Is your Zoom on? I'm on Zoom standard. If your Zoom fit, then it might. Zoom fit is dangerous when it comes to zeros. Kelsey, look at his y equals. Did he type something weird? X squared plus 2x plus 4. Bring his calculator to me. Okay, meanwhile, while I look at his calculator, go ahead. Thankfully, the next one's nice. It's already typed in for you. See if you can graph it and figure out the rate. Are you attached to anything on this? Okay, well, my automatic solution in life is to clear this bad boy out. Yeah, I don't know why it was misbehaving. Now it is. Next time it misbehaves, seriously, just reset it. It's like when you turn your phone off because it takes back. Just reset it. No mercy for it. Okay, I graph number 3. I can tell how many roots is number 3 supposed to have.
2, 3.
I can't tell if it's 2 or if it's just one spot. I got 1. Yeah, I'm thinking it might just be a 1. I don't know though. I gotta figure out where those 2 spots are. I can already tell this one's gonna be a little bit of work. Why is that?
Because it look hard.
Why? Why does it look hard?
Why does it look hard?
Yeah. There's a
It
really
doesn't look like it's like
crossing at a.
angle
Uh,
on the y-axis.
It doesn't look like it's crossing through one of those dashes, which is for whole numbers, which means it's going to be a decimal, which means pressing second table is not going to help us out any.
So
I told you I love second calculate. Second calculate does all the things I need it to do. Right now, you and I aren't trying to find a min or a max. We're trying to find a 0. But when you press 0, it still asks you to do the same stuff we just did with min and max. It asks for a left bound, so pick a spot to the left of the 0. It asks for a right bound, so pick a spot to the right of the 0. And since you think there's 2, we actually need to be very careful. Come on, monster, where are you? There you are. Okay, so I pick the spot to the left. I press enter. I'm thinking my 0 is here, but that's right. Maybe there's another one there, so I need to be very careful when I pick that right bound. I don't want to pick too far over and try to have 2 zeros at once. My calculator can only do one thing at a time. So I've got to make sure when I pick that right down, I pick it a little, I pick it in between what I think are the two roots. Now, it might not give me an answer because Seth might be wrong. It might just be 1, 0. But we're going to see if he's right. I don't actually know. It tells me there's a 0 at negative 3.99, which means there's a 0 at, I'm guessing, negative 4. So maybe I could have gotten that one from my table because it did end up being a whole number. But the other one, so 1, 0 is at negative 4. But the other 0 doesn't look like a whole number. If it's crossing, it's definitely between 2 dashes. So I'm going to have to do the exact same process. So second calculate. I know it's a 0. I'm picking a spot a little, so I'm thinking it crosses there. So my cursor is a little to the left right now, so I'm going to pick it. I got to pick a little to the right of this spot, so I'm going to go a little this way. I pick it, and then I press enter one more time and make a terrible guess, and it tells me, oh, no, wait. The only 0 was at negative 4. Yes, dear? Yeah, that's all I got is a 0 at negative 4. It only had 1 0, and it was at negative 4. Now, what's probably happened if we're thinking factoring is it was an x plus 4 squared. So if it ended up being a double root is what this happened. So it's really 2 roots. It's just they happen to both hit the same spot. If we're factoring wise and we're trying to think about that. But as for calculator wise, if your calculator gives you the same number twice, probably is only that number. Okay, so in negative 3.9997, if Alex wants to write that out, that's great. If he just wants to put negative 4, that's fine too. Well, I don't need an and, it's just negative 4. Okay, the last one is not in standard form. Can someone put it in standard form and get the group point? Braxton, you want to be brave?
No.
Okay. Archer, are you going to be brave?
Add 11 on the...
Okay, and if I add 11 to both sides, then what's my final answer?
Negative 3x squared plus 4, plus 2x plus 4.
Thank you for fixing it. Okay, so Arturo was right. We do add 11 to both sides, and I get 11 minus 7 is positive 4. But he also realized the 2x is supposed to be in the middle. It's just the little things in life. Now, if he had typed it in another way in his calculator, since everything was on one side, it still would have worked out. But math teacher-wise, you know, I like it in standard form. So, okay, we type this in our calculator. We'll see what graph we get. What did you say, man? I have 2 roots as well, and then where are those roots happening?
It's negative 1 and 1.5.
I know you said it was at negative 1. But when I look at my table, at negative 1, focus now. At negative 1, I should have seen a 0 in this column then if that was actually a root. So you're wrong. It's not a negative 1. Which probably means what then?
So it's 4?
You thought it was at negative 1, but really, doesn't it look like it's hitting a little before the dash at negative 1?
Mm-hmm.
So it's probably like a negative 0.9. So it's probably a decimal. So that table of values wasn't going to help us anyway. So we've got to second calculate this one too. So second calc. I want a 0. I pick a spot to the left of my 0. My 0 is here. Yep, I'm to the left. That's good. I got to pick a spot to the right of my 0. Let's say here. I press enter. Oh, it was negative 0.868, so that's negative 0.87, which if you rounded to negative 0.9, I would give it to you. I'm going to write negative 0.87 on my paper. But again, if you rounded to negative 0.9, I'd give it to you. The only thing I wouldn't give you all your points for is if you said negative 1. It did not. It's not a whole number. Okay, it's looking like it's 1.5 for the other 0. But I probably need to still state and calculate instead of writing 1.5. I still need to know for sure. So someone who's pressed second calculate, what was the second 0? I'm going to press guess and then it's over. It was 1.535. Yay. So we're going to say 1.5 or 1.54 is what I'm actually writing on my paper. I tend to be a 2 decimal person. Okay. If something went wrong with you, again, did you pick a spot a little to the left, a little to the right, and then you just press entering in for your yes? We have to be a little more careful when we're doing zeros than we are when we're doing max and min, because there are 2 of them. When we're doing max or min, it's just the max or just the min. But now that there are 2, Mackenzie has to be very careful that when she sets her left bound and right bound, she's only going to have 1 0 inside those 2 bounds. If she makes her bounds too big and her calculator's trying to find both zeros at the same time, she has a major issue. Okay, are there any questions about this? The final 3 are yours. And that's going to be your homework for tonight. If you want to show me you have that done before you leave the room, that would be awesome. If you've not gotten approved of your checkpoint or whatever you were behind on from Friday, you need to get that done.